Hi everyone, we're starting our next chapter, which is chapter 8, and we're looking at factorization. So factorization and expansion are considered to be opposite operations. In other words, one operation undoes the other operation. So for example, when we're looking at expansion, what we have is we have parentheses, or we have expressions in parentheses. And what we do is we expand, or we use all the forms that we learned of expansion, such as FOIL, difference of squares, perfect squares, etc. And what we do is we get rid of the parentheses. Now, as we are factorizing, what we are doing is we are working our way backward, and we're saying what two binomials, or what were the original expressions that in the parentheses gave us the expression that we now have. So if we look at the example, x plus 3 times x plus 4, if we expand that, it becomes x squared plus 7x plus 12, and we did that by using FOIL. And if we're going to factorize, what we're doing is we are replacing or placing back in the parentheses. Now, how we go about doing that is going to differ as we're going through the chapter. There are many different methods to use, and the first method we're going to be using, as you can see, the first method is going to be removing common factors. And if you look at the table that we have here, we can see that there are many different ways of factorizing, which goes from looking for difference of squares, perfect squares, grouping in pairs, sum and product, and splitting the middle term. There are other ways of doing it as well, but we'll look at those a little bit later on. All right, so what we're going to be looking at today is we're going to be looking at how to remove common factors. So when we are looking at removing a common factor, the first thing we need to do is we need to figure out what the greatest common factor is. So in other words, if I had, for example, let's look at the example I have here, which is considering the numbers 18, 24, and 36. Now if I'm looking for the greatest common factor, I'm trying to think of what's the largest number that's going to divide evenly into all three numbers. So 18, 24, and 36, the largest number that will divide evenly into all of those is going to be 6. If I look at the example I have below here, consider the numbers 42, 56, and 63. What is the greatest common factor there? Well, the largest number that I can divide all of these numbers by evenly is going to be 7. Okay, so that would be my greatest common factor. Now, how do we apply this to the expressions? Well, let's say that we had the example down here, which is 15x to the 4th y cubed plus 10x cubed y. All right, so the first thing I'm going to do is I'm going to divide this up, and I'm going to look for the greatest common factor in terms of the numbers. So I've got a 15 here, I've got a 10 over here, so that the largest number that I can remove from both of them is a 5. Now, if I open up a parentheses, I would be basically saying 15 divided by 5 will give me a 3, and 10 divided by 5 will give me a 2. Now there's a plus in between all of that. And now the next thing I look at is I say, now between x to the 4th and x cubed, what is the largest value of x I can take out? Well, that would be x cubed. So that I can say x to the 4th divided by x cubed leaves an x in the first term in the parentheses. And if I did x cubed divided by x cubed, well, that would just leave me with 1. So there's no x left inside the parentheses in the second term. And then I do the same thing with the y. What's the largest value of y that I can remove? Well, I've got a y cubed here, I've got a y there. Therefore, the largest value of y I can remove is y. So y cubed divided by y gives me a y squared in the first term. And then y divided by y will just give me 1. So that my final answer would turn out to be 5x cubed y times, in parentheses, 3xy squared plus 2. Now, in order to check to see if I did this correctly, all I would really have to do is just redistribute it, or just use the distribution property, And by using the distribution property, I can multiply it through again so that I can check to see if I'm getting the same answer, or in other words, the original question that I started out with. All right, so let's try another one. Let's try something a little bit more difficult, such as, let's try something a little more difficult, such as, okay, let's look at, I'm just going to give you an example. I'm going to make one up right now. So if I've got 20x cubed y to the 4th plus 4x squared y to the 5th, so the first thing I'm going to do is I'm going to remove my common factor from the numbers that we have here, the coefficients, and 4 is the highest number I can remove. So in removing the 4, that means that 20 divided by 4 gives me 5, and 4 divided by 4 will give me 1. Now, between the x cubed and x squared, I can remove an x squared, so I can say x cubed divided by x squared leaves me an x inside the parentheses, and an x squared divided by x squared will leave me a 1 again inside the parentheses here in the second term. And then between y to the 4th and y to the 5th, I can remove a y to the 4th, which means that y to the 4th divided by y to the 4th would technically give me 1 left over in the parentheses, and y to the 5th divided by y to the 4th would give me a y. Therefore, my final answer here would turn out to be 4x squared y to the 4th times 5x plus y. All right, so having done that, let's just do a couple of examples, such as if we have here in question B, we have negative 6x squared minus 9x. Well, the biggest factor I can remove is a negative 3x, and that what would be left over would be a 2x minus 3 inside the parentheses. And if I had 3x squared minus 8x, so I'm just using this example and that example, I can remove an x because 3 doesn't go into 8, so that I would have a 3x minus 8 left over inside the parentheses. All right. The other examples that I'd like to look at are the removing a common factor, where we're not looking at simply taking out one term, but we're taking out an entire expression. So let's look at the example that we have up here, which I'm scribbling all over. All right, so as I mentioned before, I can remove an entire expression. Now, the expression that can be removed in this particular question, let's take a look at the first question here, is I've got an x plus 1 squared and I've got an x plus 1. Now, I have two x plus 1s here in the first term, and I have one x plus 1 in the second term. So technically, I could remove an x plus 1, and what would happen is that because I removed one, it's like as if I were saying x plus 1 squared over x plus 1. So x plus 1 squared divided by x plus 1 gives me an x plus 1 left over. And if I now take the second term and I do 3 times x plus 1 and divide that by x plus 1, you see that my x plus 1 cancels out, and all that's left over is the 3. So that inside the parentheses I would just have plus 3. So in simplifying this, I would get x plus 1 times x plus 1 plus 3, which is x plus 4. Now, the alternative way, this would be a first method of working this out. Now, a second way that we could work this question out is by using some form of substitution. And what the form of substitution says is basically this. When I see the common part that needs to be removed, I can replace that entire expression with one single letter. So how about if I say, let A equal x plus 1. Now, in doing that, I can rewrite this expression as a squared plus 3a, because there were two values there were two expressions of x plus 1, and there was in the front here in the first term, and there was one term of x plus 1 in the second, so that, and it was multiplied by 3. So that a squared plus 3a is what I'm going to factorize now, or remove a common factor from. And removing a common factor here means that it becomes a times a plus 3. Now, because though my question was not written in terms of a, but it was written in terms of x plus 1 and x's and so forth, all I have to do is substitute back in x plus 1 for a, so that wherever there's an a, I will replace x plus 1 in there, so that I'll have x plus 1 multiplied by x plus 1 plus 3. And as you can see, I'm getting x plus 1 times x plus 4 as my solution. All right, let's take a look at another example, and then we'll come back to the previous page. So we've got x plus 1. Sorry, let's look at the first example. We've got x plus 2 all squared minus 3 times x plus 2. So I can remove an x plus 2 because there's 2 of them in the first term. And what's left over is 1 minus one of those terms, x plus 2, and then minus 3. So this becomes x plus 2 times x minus 1. Now if I use the second method, what I would have been doing would have been, I would have said let a equal x plus 2, so that this would become a squared minus 3a. This would go to a bracket a minus 3 in removing a common factor, and then I would substitute back in x plus 2 in for the value of a. So it would become x plus 2 times x plus 2 minus 3, and there we have x plus 2 times x minus 1. So again, we've got the exact same thing. If we take a look at the next example, we've got x plus 1 times a plus x plus 1 times b. And so what we can remove is an x plus 1. And then this one, it's a little bit easier, because if we remove the x plus 1 from both of these, what's left over inside the parentheses is just a plus b. All right, so let's just go back, though, to the previous page here, where I've got another example that's a little bit more complicated, where if we look at x minus 2 all squared plus 2x minus 4, it appears as if there's nothing here that's in common that can be removed. But if we take a look at the question more carefully, we should be able to see that I can remove a common factor from the second half of this equation, or of this expression, not equation, so that we have 2 times x minus 2. Now, in having done that, we now see that we have an x minus 2 that's common in both of these, and therefore I can remove an x minus 2, and what's left over inside the parentheses, well, from the first term I have an x minus 2 left over, and then I have a plus 2 left over, so that I end up with x minus 2 times x. And that's my final answer. Now, again, if I were to do this question using substitution, then I would have gotten to this portion here, x minus 2 all squared plus 2 times x minus 2. I would have said let a, or let any other letter, equal x minus 2. And therefore I would have had a squared plus 2a, and that's a bracket a plus 2, where a now is going to be replaced with x minus 2, so it's x minus 2 times x minus 2 plus 2. And there we have, again, x minus 2 times x. And we're done. All right. I'm going to stop right here. And what we're going to do is I have for you to do the homework. Hopefully you will be able to hear this video, unlike the last time. And all you are to do is exercise 8A, all of it. Okay, so I don't expect you to do anything else at this point. And I have also on PowerSchool for you 2 videos that you can watch, or a website, so that in case you had trouble following what I've done, you have some extra support or something else that you can watch as well. Thank you. Bye.